The key to success in the mole for my students has been seeing the mole roadmap. Let me show you what I'm talking about. Just what is a mole? A mole is 6.022 times 10 to the 23rd things. By definition, it is a number. Just like a dozen is a number. A dozen is 12. When we say we have a dozen this or a dozen that, we don't have to start out with a dozen only referring to one thing. A dozen can refer to any number of things. Well, so it is with a mole. A mole is 6.022 times 10 to the 23rd things. Atoms, molecules, electrons, floppy-eared puppy dogs, it doesn't matter. A mole, however, in chemistry, when we're talking about things related to chemistry, weighs the gram atomic weight, if we're talking about atoms, or the gram molecular weight, if we're talking about molecules. For example, suppose we have a mole of sodium atoms. A mole of sodium atoms is 6.022 times 10 to the 23rd sodium atoms, and they happen to weigh 23 grams. Suppose we're talking about a mole of water molecules. Well, we're talking about 6.022 times 10 to the 23rd water molecules, and they happen to weigh 18 grams. Well, is there more to the mole roadmap than these two items? And the answer is, oh yes. There are a number of things, but I usually use 4. Here's a third one. A mole of a gas is 22.4 liters of the gas at STP. For example, suppose you have the gas nitric oxide, NO. Well, a mole of nitric oxide is 6.022 times 10 to the 23rd molecules of nitric oxide. That mole of nitric oxide happens to weigh, well, let's see, NO. Nitrogen is 14 and oxygen 16, so it weighs 30. A mole of nitric oxide weighs 30 grams per mole. And a mole of nitric oxide, the gas, occupies 22.4 liters at STP. It's all a mole. A mole is also molarity times liters when you're talking about solutions. Now, in this little unit that we're doing today, we're not going to talk about gases and solutions. We're going to limit ourselves to masses, mole, and numbers. Suppose you were asked to calculate the number of moles in 3.82 grams of copper metal. On the mole roadmap, what you're doing is you're starting at mass over here on the right. You're starting with 3.82 grams of copper metal, and you've got to get that to moles. And here is the way you do it. You take 3.82 grams times 1 mole over 63.55 grams. Your grams cancel, and that leaves you with moles of copper metal. Okay, that was kind of easy. Let's try another one. How about calculating the number of moles in 2.9 times 10 to the 21st atoms of dysprosium? Wow. Well, let's see. We're starting with numbers of things. So we're down here at this point in the mole roadmap. And we've got to go from here to moles. In other words, from here to here. How do we do it? Well, it didn't matter if it was atoms of dysprosium or atoms of hydrogen or atoms of whatever. You take the 2.9 times 10 to the 21st atoms times a mole over 6.022 times 10 to the 23rd atoms, and you come up with a cancellation of atoms, leaving you with 4.8 times 10 to the negative third moles. Get the idea? Well, let's make it just a shade more interesting. This time, let's calculate the number of atoms in 4.26 grams of copper. Now, here's our mole roadmap. We're given 4.26 grams of copper, so we're starting out over here at mass. And you're going to have to involve the gram atomic weight of copper to do this now. That's why I've circled this over here. You're going to go from mass to moles to number, just like that. You go to moles, which is your intersection, make a left-hand turn, and come down to the number of particles. And this is the way it works, like this. So we start with 4.26 grams of our copper. And let's convert that to moles by multiplying by 1 mole over 63.55 grams. Got that? Now you're at the midway point. You are now at moles because your grams cancel. Now let's go from moles to number of atoms. It's times 6.022 times 10 to the 23rd atoms per mole. And your moles cancel. And what does this leave us with? I calculated it to be 4.04 times 10 to the 22nd atoms. That's right. And with the mole roadmap, you won't get confused about what to do, so keep it in mind. Let's try one more problem. Calculate the number of atoms of any kind in 1.03 grams ammonium sulfate. Well, we start with our 1.03 grams, and we get this to moles. It's times 1 mole over 196 grams. Now we are at moles of ammonium sulfate. Now let's find out how many molecules we have. Grams cancel, that's why we know we're at moles. Times 6.022 times 10 to the 23rd molecules per mole. And moles cancel. So this tells us now that we have a certain number of molecules of ammonium sulfate, if you will. Well, that doesn't answer the question because the question asks us the number of atoms. So we multiply that by 15 atoms per molecule. Now, where did we get 15? Well, we have 2 nitrogens and 8 hydrogens. That gives us 10. And 1 sulfur is 11, and 4 oxygens makes 15. That's where we got 15 atoms per molecule. And that is going to give us then 4.75 times 10 to the 22nd atoms. The key to working these is keeping the mole roadmap firmly in mind so you will know to go to moles and to make the transition from moles to the unit that you're going to need that will lead you to the solution for your problem. There is our answer. Brought to you courtesy of Chemistry Professor, offering complete chemistry courses on DVD. Join us at our website at www.chemistryprofessor.com.